Now, we discuss the idea of multiplication in matrices. What do you mean by a matrix multiplication? There are two concepts. One is multiplication by a number. This number is called a scalar, and we term the process of multiplication as the scalar multiplication. Now the question is, how can you multiply a matrix by a scalar? Here is the matrix A, 2, minus 1, 1, 3. What will be the value of 3 times A? Multiplying the matrix A by 3 means multiplying each element of A by 3. So the resultant matrix becomes 3A equal to 3 into 2, 3 into minus 1, 1 into 3, 3 into 3. This is the matrix 6 minus 3, 3, 9. Let's do an example. Find x and y if 3 times row matrix 4x plus 2 times row matrix y minus 3 is equal to the row matrix 10, 0. We do this in 4 steps. First, we will do the scalar multiplication as we did previously. Thus, the elements of the first matrix are now 12, 3x, and that of the second matrix are 2y minus 6. It is equal to the matrix on the right hand side 10, 0. In the second step, we add the result matrices on the left hand side. We can equate the corresponding elements of the matrices on left hand side and right hand side, and we do that as the third step. Thus, we get 2 equations in 2 unknown variables. And finally, we solve the equations for x and y. We get the values x equal to 2 and y equal to minus 1. Now we discuss how to multiply 2 matrices. But before that, let us consider 2 vectors. Remember, single row or single column matrices are called row or column vectors respectively. The first one is a row vector A 1 0 minus 1, and the second one is a column vector B 2 1 1. Now we are going to define the product AB. We are going to calculate the first element of the new matrix AB. For that, we take the first element from A and multiply with the first element of B. Then take the second element from A and multiply it with the second element from B. Thirdly, we take the last element from A and multiply with the last element from B. Then we take the sum of these 3 products, and this will be the element of the product AB. Also, this is the only element which the matrix AB has. Now let's replace the first row vector with a 2 by 3 matrix and see how the multiplication is done. We take the first row for A and multiply with the column vector B as we did previously. So we get the value 1 as the first element of the product AB. Now what to do with the second row of the matrix A? We do the same steps as we did just now, taking the second row of A. So we get 3 as the sum of products. Now the question is, where will we write this 3 in the product matrix AB? Remember, we took row 2 of A and column 1 of B to form this number 3. This indicates 3 is the element on the row 2 and column 1 of the product matrix AB. Observe that there are 2 rows in the first matrix A and 1 column in the second matrix B. Hence, there will be 2 rows and 1 column in the product AB. Interestingly, note the number of columns of A and rows of B. They are equal. In fact, this is the condition for 2 matrices to be able to multiply. The number of columns of the first matrix has to be same as the number of rows of the second matrix. Next, consider the below matrices A and B. A is of order 3 by 2 and B is of order 2 by 2. Obviously, the product AB exists as the number of columns of A and number of rows of B are equal. We also learned in the previous step that the order of the product AB will be 3 by 2. So, AB will have 3 rows and 2 columns. Now, as we did earlier, we begin with the first row of A and calculate the sum of products with the first column of B and then proceed to the second column of B. Then move on to the second row of A and repeat the same. And finally, to the sum of products of the third row of A with the columns of B. Here comes an important question. Is it possible to multiply any two matrices? In the previous case, we multiplied A by B. What if we try to multiply B by A? Let's write down the order, first of B and then of A. We can see the number of columns of B is 2 and the number of rows of A is 3. And they obviously are not equal, violating the condition for the compatibility for multiplication. Hence, the product BA does not exist. This means even if AB exists, that does not mean BA exists. Consider these two 2 by 2 matrices. Let's try to find the products AB and BA. Even though AB and BA exist, AB need not be equal to BA. So, the matrix multiplication is not commutative. Now consider these matrices. Matrix A is a 2 by 2 matrix, minus 3, 3, 2, minus 2, and B the 2 by 2 matrix 4, 6, 4, 6. Obviously, they are compatible for multiplication being square matrices of the same order. Let's see what would be the product of these matrices. Interestingly, it is a zero matrix. The interesting fact is that we multiplied two non-zero matrices and we got the result as a zero matrix. This is different from what we see in the real number system, where two non-zero numbers can never produce 0 as their product. This means in the matrix space, the product of two matrices being 0 does not imply either one of them is a zero matrix. This is all for this session. Some more conclusions and concepts are yet to be discussed, but that we will do in the next session. So don't forget to subscribe the channel and enable the notifications so that you may receive the notifications as and when the videos are released. So stay tuned. Thanks for watching. Have a great learning time.